Welcome to today's lesson. So colleagues, I wanted to do this last part for question 1 under the limit for test 1. So they're saying this is the limit as x approaches infinite for this part and also this part. So having natural log of x, for the first part we're having natural log of x over what? Over x. Now for x as it approaches infinite for this, for the top part we know that infinite of natural log is infinite, then for x it's also infinite. This tells you what? You're supposed to use L'Hopital's rule. And this is one of the standard integrals which you're just supposed to know, because we know that when you differentiate the top part, we're just going to get 1 over x. Then for the bottom part, you're going to get what? X. 1. Then applying the limit as x approaches infinite, it gives you 0. So that's why I'm saying that this is one of the standard what? Limits which you'll be given. So for this part, you know that it's 0. The only interesting part was here. So here you can solve it using two methods. One, you can just multiply the numerator and denominator, which is 1, by the conjugate of the numerator. The other one is factorization, which I really prefer myself. So if we factor this out, we factor this, you can just start by factoring x squared inside. So for this, we are going to get this. And for factorization, you're not supposed to change anything. You're not supposed to change the meaning, but you're just supposed to make it look or become something which you can evaluate and find the answer for. So if you look at this, if I multiply x by 1, I'm still going back there, the same. So isn't it? So now the root of x squared will be x, and I'll have x here and I'll have x here. So it's better I just factor it out. Just factor the x out. So I have 1 plus t over what? X squared, like that. Then minus, I'll have the root here of 1 minus t over what? X squared. Now, remember, AB is the same as what? B over 1 over A, according to indices. Or algebra, just normal algebra. Because we know that 1 divided by 1 over A is the same as A times B. Isn't it? So now, I'm just going to write A in terms of this. So I'll have 1 plus t over x squared, like that. Then minus the root of 1 minus t over what? X squared. Then this all over what? 1 over x. Remember, the limit was x approaching what? Infinite. So if I put infinite here, what am I going to get? A 0. So for the numerator, I'm going to get a 0. I know the denominator and also the numerator. So 0 here, 0 here. So it's root of 1 minus root of 1, which is what? 0. So both it's giving me that. What does this tell us? It tells us a very good thing. So that we can use what? L'Hopital's rule. So it differentiates the numerator separately and also the denominator separately. So for the first part, when you differentiate this, we are going to get half 1 plus t over what? X squared, like this. Then to the power negative 1 over 2. Then we're going to multiply this with the derivative of the inner part. So this will be 2t over x to the power 3. Then this will be negative. Then we do the same also for this part. We're going to have half 1 minus t over x squared, like this, to the power negative half. Then we multiply it with what? This will be, this becomes positive 2t over x to the power 3. Then for the numerator, we are done. Then the denominator will have negative 1 over what? X squared. So to simplify, what simplifies is we can see the 2 and the 2 goes. The 2 and the 2 goes here, isn't it? So what we're just going to have is 1 over x cubed 1 plus t over x squared to the power negative 1 over 2 minus, we'll have, there's a t here, it's supposed to be a t over x cubed 1 minus, like this. Nice. Then this is all over negative 1 over x squared. So if you look at this, since we have negative 1 over x squared and on top we have 1 over x cubed, 1 over x cubed, so we can just try to work it out here. We have t over x cubed divided by 1 over x squared. You can see what will happen. So this goes on top when we introduce it to be multiplication. So I have t over x. So here we have t over x and t over x. And remember the limit was what? As x, was it approaching what? Infinite. So if you put infinite for anything, t over x or 1 over x, we know that it will be 0. So this term will become what? 0 due to this. So I'll say 1 plus t over x squared, the power negative half, like that. Nicely, we have x here. We have 1 minus t over x what? Squared. Isn't it? So the bottom part has gone. So this will become, this becomes what? Oh, there was a negative here. When you differentiate, there will be negative here, negative here. So now the negatives will go due to this, the negative, to make everything positive. So now for the limit as x approaches what? Infinite, this will be 0 and this part will be 0, making everything what? 0. Now remember, for the entire limit, the first thing we found was what? A 2 plus a 1 plus a 0. So for question 1, the final answer will be what? Will be 3. Thank you for your attention. See you. Bye bye.